All right. So the other thing we do when we're comparing the proportions of two groups, other than just trying to determine if there is a real statistical difference between the two, is we would like to try to estimate what the actual difference is. So here's the same problem. We've got group one of trying to uh, of smokers trying to using a program to quit smoking, and we see that 25% of them were successful using the program one. In group two, we had 15% that were successful using program two. And so, what's the difference between these two? That's pretty simple. That's 0.258 minus 0.151. So, there's a 10 percentage points of difference between um, the people that use program one versus the people that use program two. So, we might like to say, therefore, we think for all people that try all of these programs, for all people trying to quit, you've got 10 percentage points higher chance of being successful with program one than program two, right? We're trying to estimate the population difference, right? So we're trying to say, oh, well, this is the difference between P1 minus P2 as an estimate. And that's our point estimate, but we've talked about this. The better way to estimate it is to try to create a confidence interval estimate um, for the difference between P1 minus P2, because that gives us a broader range. It's a little more intellectually honest. It's a little more accurate. There's a better chance that we are accurate, that we've actually got it. If we just say there's a 10% difference here between the two, 10 percentage points difference, that doesn't give us much room. Plus, remember, with confidence intervals, you get to state your level of how confident you are. So it turns out that to find the confidence interval estimate for differences between proportions, it's going to look a lot like what we've done in the past. So we take the difference in the sample proportions. Remember, when we use p hat, that's the samples. So that's going to be the difference plus or minus an error. That's how we do all of our confidence intervals. We take the value we got from our sample and we do plus or minus an error on it. So P1 minus P2 we've already done, that's 0.107. So the real question is, what is the error formula here? So the error formula, and that's the thing that has always been different for us, is the z-score associated with how confident our confidence level times P1 hat Q1 hat over N sub 1 plus P2 hat Q2 hat over N sub 2. So it's a little bit more complicated, but that is the formula for finding the error in our confidence interval. All right. So for in our particular case, um, the P1 minus P1 hat minus P2 hat is already found, and that is 0.107. And then we need to plus or minus our error. So let's quickly calculate our error. Now let's suppose we are creating a 95% confidence interval. If we're creating the 95% confidence interval, then our z-score is 1.96. So let's do this. Let's put this in here. Find the 95% confidence interval estimate for the difference between the two proportions. So it's going to be 1.96. That's what we've always used. And then here we go. So P1 hat is 0.258. Q1 hat is 1 minus that. So 0.742 over N sub 1, which is 198. Plus P2 hat is 0.151 times Q2 hat, which is 0.849, all over 199. And that's going to be our error. Let me throw that into my calculator. And so I get, if everything went correct, 0.0786. It keeps going, of course, but we're going to go ahead and round that off to 3 decimal places. So 0.079 is what we'll use as our error. All right. So 1.107 plus or minus 0.079 gives us that the difference between the population proportions, notice I'm just using p's here, is between 0.028 and 0.186, to basically 3%, let's just call it 3% and 18%. That's the difference. That is the confidence interval, so we would want to make sure we include that. So this is the 95% confidence interval estimate for the difference between the two proportions. So we think program 1 is better than program 2 somewhere between 3 to 18 percentage points. All right. Now what's significant there is this interval does not contain 0, right? It runs from basically 3 to 18. 0 is not in it, which if 0 was in it, 0 represents the case where there is no difference between these two proportions. But we're 95% confident that program 1 is at least 3% percentage points better than program 2. Okay? And so that's how we calculate confidence intervals, estimates for the difference between two proportions. Now you can do this on your calculator. All right. So your calculator, if you were doing this on your calculator, you would go to, let's type this in, or you'd go to stats again. You're going to go to tests, and what we're looking for here is a 2-prop z interval. 2-prop z interval. You're using two proportions. You're finding the interval estimate for the difference between the two the two proportions, and that will spit out all of this for you.